Hello and welcome to a new lesson. We are now going to learn how to patch memory directly in order to change the serial key. The objective for CrackMe9 is firstly to find the correct serial key, and once you have found it, try to change it to another serial key of your choice. So first, let us download CrackMe9 from this website. Click on the download link and click on download here again. After you have downloaded it, just cut it and put it in your C drive in the CrackMe's folder. Then unzip it. The password is crackinglessons.com. Now that you unzipped it, let's rename the folder. We can delete the zip file. We'll rename the folder with the prefix 10.0 followed by CrackMe9. Open it with Detect It Easy. And we see that it is compiled with Boolean C++ and linked with Turbo Linker, and the entry point offset is 2254. If we run it, we will get a window asking us to enter the serial key. If we enter a wrong serial key, click on button check. We get the error message saying wrong key. Click OK. So the objective is to find the correct serial key. And then, secondly, once you have found it, change it to a different key of your choice. So the tip is, you should look for strings. Look for the strings, the error string, sorry, wrong key. Once you have found the error string, then you should look around the area to see where the correct key is being loaded to compare with the one that you enter. Once you found the address for the correct key that is being loaded from the memory, go to the memory directly and change it to any key that you like. So that is the tip. Give it a try first before you see the solution. I will give you the explanation and solution in the next lesson. So in the meanwhile, good luck. Welcome back. Let us start our cracking with x64dbg. We'll open it now with x64dbg, and we are at the breakpoint. Click on run, enter any key, click on check, and we see a sorry, wrong key message. So we are going to search for this string and analyze the code around that area. So right click, make sure you're in user mode, and then here go to search for current module, string references. And now the string search is complete, and this is the string that we are looking for. Let's move to the address by double clicking here. So we have two strings. The bad string is here and the good string is here. And the jump here decides which string to show. So the jump will only happen if the zero flag is 1. So we can put a breakpoint here and restart. Run to our breakpoint. Before that, we have to enter something. Click check. And we are now at the breakpoint. And from here we see that it is not going to jump. So if it's not going to jump, it will show the bad message. It is not going to jump because the zero flag is not set to 1. So just before the jump, there should be a test or a compare. Over here we have a test. So this test is the one which determines the zero flag. So in order for zero flag to be set to 1, ASI must be 0. So test means testing whether the value in the register ESI is 0. So if the ESI value is not 0, the zero flag is not set. Then we need to analyze further what sets the value in ESI. We can check up here and see that this line is the one which sets the value in ESI over here. So we can check EAX now by putting a breakpoint. Remove this, run, enter anything, check, and we hit our new breakpoint. And now we see the value in EAX is FFFF. This is no good. We want it to be 0, not FFFF. So that means even before this, EAX has already been set to FFFF. So let us investigate which of the instruction here set it to FFFF. So to investigate that, we can put a breakpoint even high up here and remove this. Then restart, run, enter anything, click check. So we're now at our new breakpoint, and notice the EAX is not FFFF and it is also not 0. What we want is 0. So let's analyze by pressing F8 and keeping a lookout to see when is EAX set to FFFF. Keep on pressing F8. Okay, immediately after this call, EAX became FFFF. So that is bad. That means this call is a 1 which causes EAX to become FFFF. So since in this call, it is where something is happening. Some kind of string comparison maybe is being done. And if you look up here, we can also see that in preparation for the string comparisons, there is something being loaded. And you can see here, a string is being loaded. Yes? So what is the purpose of this string? So it is it is loading something to this register. Yes, you can see that over there. So anyway, let us now move our focus to this line, put a breakpoint, remove this, and we are going to come back here and step into it. So reset, run, press RA, check, and now we are going to step into this by pressing F7, and then we can move F8 to analyze. And you can see it is performing some kind of comparison. Compare strings, as you can see here. Yes, so it is already completed this call and has already loaded EAX with FFFF. That means the string that is comparing is this. That means this is the one which is the serial key that we are looking for. So this serial key is loaded from where? This serial key is loaded from this memory address. This is the first place where it loads. It loads the serial key from here to the stack. So over here is where we should look for this serial key, the address 71822A. So we can click on this and go to the address by clicking this, right click, follow in dump 71822A. And true enough, you can see your serial key in this memory location. So what we want to do now is to patch this serial key to our own serial key. So to do that, we can select all this like this, and then right click, binary, edit. And over here, make sure you check on keep size, and then down here, you change to any serial key you want. We can make it reverse. Instead of ABC 1 2 3 4 5 6, we can reverse it. We can put CBA dash 654321. Click OK. So now you can see we have patched it. We have patched it with our own serial key. Yes? Alright, so now we can click run, and it shows the wrong serial key. That's fine. Now we enter our own serial key which we patched, which we set in the memory. CBA 654321. Click check and click run, and we get correct key. So we have already hacked this by modifying the memory location directly and changing it to our own serial key. So to make this permanent, we need to patch it. So we click File, Patch File, and then click Patch File again. And here, let's give a new name. Dash patch. Save. Click OK. Now we can open the patch file and run it. Enter our own serial key, which is this. Click check. Yes, it's correct serial key. Yes, so that's it. We have solved this challenge. We found the correct serial key and we change it to a different key of our choice. So this is how we do memory patching. Thank you for watching.